Thank you very much. I promise you it's going to be a fun talk. If you want to follow the slides, you can get them at this URL. They're available right now. I've made a couple of small adjustments, and I'll actually push the new version of the slides to that URL. It's yto.io/xpromise. So if you go there, you will be able to download the slides. Also, my Twitter is over there, and a lot of those things, some of the examples are going to be available on GitHub. I'll show you the URL for slides again, so don't just worry about scribbling things down. Oh,
it's good.
I told you I can do it without the microphone. So people often ask me, they come to me and say, Yuri, why are promises so awesome? No, in reality, the question isn't usually asked quite that way, but I think that why promises is an important question to start with, because oftentimes, even diehard fans of promises, I think, don't have necessarily the best answer to what is it that they love so much about promises, or I think sometimes people love promises for what, from my perspective, might be a somewhat wrong reason. So let's first talk about why promises. And if you're wondering what the hell are promises, I'll answer that question in a second. So when we're looking at when we're asking why promises in JavaScript, we first, of course, have to think, well, as opposed to what? And the truth is, JavaScript is asynchronous coding in JavaScript is a bit of a challenge because JavaScript can't wait, right? So when in other programming languages, we could do things like cursor equals, do query, and then in between, we're just going to pause. In JavaScript, we cannot do that. So what do we do instead? Well, all variations on all solutions to that problem really ultimately are variations on callbacks, right? So in that sense, we can't necessarily say that we're going to use promises instead of callbacks because promises use callbacks, right? I mean, ultimately, all of those solutions involve us making a request and then at some point providing a function that is going to get called when the results of that request are available at some later point, if at some point they become available. And using the same method, of course, for also catching errors. So, but let's consider, though, for a second, but the most common sort of the standard approach to this, the most baseline against which we may want to compare promises would be what I would call node-style callbacks. So node-style callbacks are basically where you call a function, you provide some arguments, and you provide a callback function that will get called back if things completed successfully or if there was an error, and if there's an error, so you're going to be provided about the information about it. So this code in Node, so if we want to make a request to the server, we will write something like that. So we have request, the first argument is the URL, the second argument is the callback function, and then meanwhile, we can do something else. So do something else, in this case, is going to get called before the result is available from the server and before it can get handled. Now, the problem with that is the well-known pyramid of doom. Right? The pyramid of doom arises when we start making passing callbacks down the call stack, because in this case, we want to make a query. We want to query the database to pull out a URL, for instance, from one of is going to come back from the database. And then we're going to make a request to the server. And then we're going to do something else. And then we're going to do yet another thing. And all through this, we need to actually be passing callbacks further and further down. And this ends up looking insanely ugly. It's really hard to understand. And why it's hard to decompose, and why is it such a mess? And I think this is a question that's really worth pausing, because why? It's not such a mess just because it's asynchronous. It's such a mess because we actually, by this architecture, we are committed to providing the handler at the same time as we make a request. Right? That's really the fundamental problem with this. Because when we make a request for the query, so when we make a request for the, say, the server in the middle of this pyramid of doom, we need to, at that point, know what is it we're actually going to do. But what we're going to do depends on where we got called from. That's why we actually end up having to pass callbacks through multiple rounds, right? And so this is the fundamental problem that promises solve for us. So in contrast, how does this code look with promises? I'm going to give you some examples that sort of use AngularJS syntax, but you don't really need to know AngularJS to understand this. So in this case, we first make a request. We do $HTTP.get, and this returns us an object, which we can then use to attach a callback later. I mean, the key difference there is that we don't have to provide the callback at the same time. We can provide this callback later, and also we can provide the callback in another place. So the function that actually makes a request really does not need to be concerning itself at all in this setup with what is actually going to happen when the result is available. All it needs to do is it needs to set up the request, make a request, and return a promise. And the caller now has the responsibility to decide what to do later, and the caller can either go ahead and actually attach callbacks, or the caller can pass this promise further on, right? And this is the key sort of architectural difference here. And of course, another really interesting thing, and we'll see some examples of later of using that, is we can later use the same object to attach other callbacks to it. So we're not really limited to, so with a sort of node-style callback structure, we've got one chance to attach a callback. So we're making a request, and now we need to decide what are we going to do with it. With this approach, you get back an object which you can use to attach later as many callbacks as you want, all of those callbacks being attached to the result of the same request. And of course, the important thing we'll see later when we chain them, we are actually attaching this not to any kind of result of further processing, but to the initial, to the same. So the callback that we attach in the bottom will end up getting exact same result as the first callback that we attach. This gives us a lot of flexibility. Now, it's important to note that, of course, promises are not always the answer to all problems. Occasionally, they're not the answer. And so, and the most important alternative, now I think that between callbacks, between promises and node-style callbacks, promises win every time. I think it's really that simple, every time. I have not seen cases where you really could sort of say that, yeah, here really we need to go with a node-style callback because promises won't do. However, promises make certain semantic assumptions, and which are not always appropriate. And the main alternative is a publish-subscribe model. Now, publish-subscribe model is not really better or worse than promises. It just fundamentally actually has different semantics. So I think it's worth thinking a little bit through this. So what are the difference between, so in the case of publish-subscribe, in case of a promise, we make a request. In exchange for a request, we get a promise, which is an object which we can use to attach callbacks later, which are very specific to that request. In case of publish-subscribe, we just have an opportunity to subscribe for events, and someone else has an opportunity to actually publish events to the same channel. So what are the key differences? Well, promises work best for modeling things that happen once, right? So when we make an HTTP request, we expect to get back one response, right? We don't expect, once we've got the response to our initial request, we don't expect the server to suddenly come back later, half an hour later, and say, oh, I've got some more stuff for you. No, right? Once we're done, we're done. Publish-subscribe works best when you want to model events that are going to actually happen many times. So for instance, when you gave user a button, the user can click on this button once, they can click on this button second time, they can click on this button third time. It's a recurrent event. So that would be better modeled using publish-subscribe or sort of event system. The second big difference is that promises, by design, apply the same treatment to past and future. So this is the important thing, is that so when I use a promise object to attach a callback, at that point I don't care whether the result of that request has already become available, or if it will become available in the future. If it already is available, then my callback will fire immediately. Not immediately, I mean on the next turn in the event queue. If it will become available at some later point, it will happen later. But the point is that with a promise, when you attach a callback to a promise, you actually get the past resolution, right? So you can't really, in a way, be too late, right? The normal standard implementation of publish-subscribe, really, you would only, now it varies, but the standard approach is you only care about the future. You basically say, I am registering an event listener on this button now, and I want to get any future clicks. If the user have been sort of clicking on this button many times before you attach the listener, then you normally don't care about those. So that's another important difference. Again, typically when you're making requests to the server, you really actually do want, as we'll see in most cases, I mean, because they're attached to a particular request, you do want to get the response even if you actually came late. And we'll see some examples later of where this actually becomes really handy. And then finally, I've sort of alluded to this already, promises can be easily matched with requests, right? So that's kind of ends up being there. So they give us some flexibility in the sense that we actually can attach handlers later. But when we attach handlers later, we actually know what's the underlying chain of requests onto which we attach this handler. Publish, subscribe usually provide us quite a bit more distance with underlying requests, right? So we usually, with a publish, subscribe, we kind of take the approach is that things just happen. We didn't really ask for them. So with promises, we made a request, we later want to get the result. With publish, subscribe, we're just sort of assuming that things just happen. We just want to be notified when they do happen. So I would say that at least in my experience, more often than not, promises are the actual abstraction that you look, but it's important to watch out for the fact that sometimes the semantics really dictate that you go with publish, subscribe, either because you actually want really a lot more abstraction than promises give you from the request, because you only care about the future, or because you really are modeling, and most importantly, because you're modeling future events. Now, promises can be a little bit confusing, and so I want to spend a little bit of time just kind of clarifying some things about promises so that we all, so you don't end up not using promises because you just find them confusing. So oftentimes, some people who are into promises really like long promise chains. So some people think that code like this is awesome, that this is what promise is all about. Now, this is not what promise is all about. This is awful style. Don't do this. And the reason it's awful style is not just because it's hard to debug, but because it actually turns reasonable people away from promises. I mean, if you're looking at this code and you're saying, wow, why would I want to do something like that? I'm with you, so don't. Now, that said, since we do end up seeing that style quite a bit, and I think in moderation sometimes it makes sense, right? Don't overdo it, but in moderation it makes sense. Let's actually figure out what's happening here. Because, I mean, of course, and I think that's a problem with fluent interfaces in general. It's sometimes a little hard to make sense of what's going on, because really what you're looking here in a way is one giant statement, first of all, of chained calls. And it's hard to it's easy to miss the fact that what really happens here is we make a request, we get a promise, we attach a callback to that promise. In the process of attaching the callback, we get a new promise. We then attach a callback to that promise, which gives us a new promise in return, and so on, right? Now, by the way, so what we're trying to do here is we are making a request to the server. We are going to then extract the data field from the response. We are then going to do a synchronous filtering of the data we got to remove all just items we're interested in. And then we're going to attach that object to our view model. And finally, we're going to catch errors, right? So I think the easiest way to actually really make sense of something like that is to actually go through the following exercise. I will give you a really condensed version of this, but I actually encourage anyone who's confused by this code to really go through that exercise slowly and really pause to make sense. So let's imagine that instead of using the fluent interface, which can look a little sexy, but at the same time I think ends up being really confusing because it really hides sort of what's going on, let's instead go ahead and actually assign a variable to every step. So here's what this code is going to end up looking in this case. The first thing we do is we make it's the same code, right, but just now with variables. We start by making an HTTP request, and whatever comes back to us is a promise, and we're going to save it in a variable that we're going to call response promise. It's a response promise in the sense that it's a promise for a response. It's a promise such that if we attach a callback to it, we will then, if this request goes successfully, the callback will get called with the actual response. Now, what we then do is we attach we call .then method on the response promise, provide a new callback, a callback that now pulls out the data field from the response. And the result of calling .then is a new promise, and let's go ahead and actually give that promise a new name. So we save it in a new variable called tasks promise. So this is a promise for tasks. If we attach callbacks to that, those callbacks will get called with the actual list of tasks. So now let's go and do another .then. So we're going to do tasks.then. And the important thing is that, as you can see now, the tasks.then gives us yet another promise. We're going to call it filter tasks promise. And this is internally, basically, it goes ahead. So in every step, as you can see, what happens is we get a promise for the next step. We get a promise for the output of the callback function. And then finally, we could do the same thing with the VM update promise. And finally, we can actually get an error handler promise, which will we get by attaching an error callback to the promise of updating the view model. Okay? Now, So what you can see here, I think this is an important thing, is that we've now created 5 variables. There are 5 promises, which makes it really clear that there really are 5 different promises that are going on, right? And one of the things that immediately should jump at you is that this last promise here, the error handler promise, we are not actually doing anything with this. And this is something that really you ought to think about, because what this means is that if something goes wrong in our error handler, no one cares, okay? Because we did not attach any further callback. So whatever happens, the error handler promise is going to be sitting out there, but no one is actually going to look at it, okay? So this is something that also becomes quite a bit more apparent with this design. So the other thing that actually becomes clear is that the promises, the earlier promises that we've saved in those variables, they're still there, and they're still unmodified. So when we attach a .then to response promise initially, the function supplied through .then will get called with a response. If we do that again by attaching another callback to the same promise, it will get called with the same response, right? We can attach 100 callbacks, and they will all get called with the same response. What happens later with the other promise, when we attach other callbacks, doesn't actually matter, because each one of those steps generates a new promise. And so we can actually go back and attach now callbacks to any one of the 5 promises, and depending on which one we attach it to. And so we get different results. So what the chained approach, of course, does then is that it basically conflates all of them to a single call, where really, essentially, we are not giving names to any of the promises, but we're essentially doing the same thing. Every time we get a new promise, and we attach the callback to that. I actually encourage you, I mean, if you're still confused at this point, then I encourage you to kind of go through those steps slowly with console log and to make sense of it, because once you make sense of this, then everything else about promises just suddenly makes way more sense. Now, to further understand this, we need to kind of consider what I would call the sort of the fundamental axiom of promises. And this is that with promises, .then returns a promise, always, like always. So this just, you can take this to the bank, right? Unless your promise library is not written correctly, is not up to specification, your .then will always return a promise, no matter what you do there. Now, so which is to say that if we have code like this, data promise, get data async, and then we do transform data promise, which is data promise.then, and then we provide a callback, and inside of a callback we do something. It doesn't matter what transform data returns. The transform data can return null, it can return a number, it can return a promise, it can throw an error. It does not matter. Regardless of what happens, the value of transform data promise at the end of it is going to be a promise. It does not matter whether any of the what happened prior to that, right? Now, what varies is that what kind of promise it's going to be. So it's really, I think, worthwhile considering 3 common cases. So case 1. So, I mean, we'll look at basically the 3 cases. Depending on what the callback function returns, what kind of promise are we going to get out of .then? Now, with all of those things, it's kind of important to keep in mind that, I mean, when I present it that way, I am cheating perhaps a little bit, right? Because it's not actually quite straightforward, because the .then will give us a promise before the callback actually returns, right? So it's not so much that we actually get a different promise, but maybe a better way to say is that we're going to get the same promise, regardless of what callback returns, because the callback is only going to return later. But so what this really is that depending on what the callback does, what's going to be the behavior of the promise that we get back from .then. So step 1. Simplest case. If a callback returns successfully a regular value, then we will get back, and by regular value, I mean anything other than a promise. It means it does not throw an error, and it does not return a promise. It returns a number, it returns an array, it returns an object, and an object without a .then method, anything, then the promise that we got from .then will then resolve to that value. That's a really simple case. So if inside of the callback we say return 1, then if we attach a callback to this promise, then it's going to get called with 1. The second case that's a little bit confusing, but is actually really, really powerful, which is that if the callback actually returns a promise, then the promise returned by .then will resolve not to whatever callback actually returned, which is a promise, but to the value of the resolution value of that promise. And it will consequently resolve to it when the promise returned by callback resolves, right? Now, this is a little confusing, but it's actually also amazing, because what this means is that the promise that you get from .then, so in cases where your callback returns a promise, the promise that you get from .then is almost kind of like the same thing. I mean, it behaves in almost the same way as the promise that .then will return to you later. But the amazing thing is that you get to have that promise ahead of time. Right? You get to have it when the underlying promise, the promise that it mimics, doesn't even yet exist. So that ends up being very powerful. And then finally, the third option is if the callback throws an error, then we still get a promise. Now, this is a really important thing to realize. We still get a promise, but this time we get a promise that rejects with the exception that was thrown inside of the callback. So what this means is that, and then finally, maybe worth mentioning here, but if your callback never gets called because instead the earlier promise rejects, then the promise returned by .then will also reject. So what this means combined is that regardless of what you do inside of your callback, you're always going to get back a promise unless whoever was implementing your promise library has really screwed it up, and usually they don't. So, so let's talk a little bit about rejections, because rejections can end up being confusing with promises and can be really frustrating if you're kind of looking for the wrong kind of behavior. If you're looking for behavior that's different from how they actually behave, they can be insanely frustrating. So let's imagine we do encounter sort of a chain promise like this. Again, I would sort of discourage you from doing it this way, but let's say that this is the code we're looking at. So what we did is we made a request, we attached a handler to it, which extracts data. To the return promise, we attached another handler that actually now does asynchronous. And notice that the nice thing is that this completely hides from us. From the perspective of later steps, we really don't care if the step inside the callback was synchronous or asynchronous, because promises, the actual values returned by callback and promises for those values are actually treated the same way in further steps. They become identical. And then finally, in the last part, we actually attach two functions. The first one is the success handler, and the second one is the error handler. Now, let's imagine something unfortunate happens, and we get an error thrown in response.data. Right? Let's say that when that function gets called, it turned out that response is actually null, and consequently, our attempt to extract response.data throws an exception. Now, so what will happen is this exception is going to not get propagated as an exception because, as I said, the code that happens inside .then never throws an exception. Or rather, the exceptions inside .then are all caught by your promise library. So what will happen instead is that the first .then will give us a promise, and that promise will now reject. Since that promise rejects, the callbacks attached to it will also reject. And so consequently, this rejection will sort of bubble down and will eventually result in the firing of this callback. Okay, so this callback is going to get fired because earlier up in the chain we threw an exception, and that exception got converted into a rejection. Now, what if we actually have an exception here? Well, it turns out it's the same thing, right? So this step also ends up so now the first .then returns an actual promise, a promise that succeeds, but the second callback gets called, the second callback throws an exception. Consequently, the promise returned by the second .then now rejects, and as a result, this gets caught by the error handler here again. So far, so good. Now let's consider the third case, which is a little unintuitive. What if we get an error right here? What you will find is that nothing happens. That error just disappears. Now the reason it's like no one hears your scream in space, right? Why does this happen? Because this can be insanely frustrating and what happens is that we have to look at the structure of this .then. Those two functions, they are provided as alternative callbacks on the promise that we reference above, right? So this is on the promise that returned by the second .then, we're attaching two callbacks in parallel. One is the success case, and one is the error case. The error handler in that case is specifically provided to catch errors in the previous step. It's not catching errors that happen in the alternative callback. So those two callbacks, they're not provided as alternative, as a backup, as one being backup for the other. those two callbacks are provided as if the previous promise resolves, do the first. If the previous promise rejects, do the second. In this case, the previous promise resolves successfully, so we proceed to execute the success callback. The success callback throws an error, and the result of this is that the promise returned by this last dot then, the one that marked in red, is going to be rejected. But as you notice, there is no callbacks that are being assigned to that promise. No one actually is listening. No one is watching the result of the last step. So there's actually a fairly simple solution for that, which is make sure to actually always have an error handler step at the very end. Now, in this case, what I'm going to do is I'm going to attach yet another handler. I'm going to this time skip the success handler. The reason I skip the success handler is because, I mean, when the success handler is null, it cannot possibly fail, right? And instead, I just provide the error handler. Now, this error handler will catch everything that happens up to this point. Now, the one thing to really watch out at this point, though, is that your error handler can still fail, right? So in this case, if it so happens that $log is null, and or $log.error is not a function, then we will get exception on the next to last line, right? We will get exception in our error handling, and that exception is going to get swallowed, right? So usually, my recommendation would be that you actually want to go for really back things up with really, really dumb, bulletproof error handlers that really are not going to fail. So you probably want to first do an error handler that maybe actually does something user-friendly, but then in the end, you really want to provide just simply, so instead, in fact, an improvement over this code would be instead of providing function and you defining a new function and actually making a call, I would just say do $log.error. And in that case, we will actually get an error earlier at the time when this code gets called initially, rather than getting it later when the callbacks actually start failing. So this actually ends up being better, but there is also another really important alternative, which actually often ends up working even better. And this is called passing the buck. The last dot then returns a promise. And if we really want to pass the responsibility for dealing with errors onto someone else, all we need to do is we just need to return this last promise. So if we put magically, if we put return in front of this whole thing, then we are returning the value that returned by the last dot then, and that whoever gets it, so whoever gets the return value from our function now has an opportunity to attach error handlers. Now, whenever doing something like that, you're kind of trusting your caller to do the right thing, right? You're really basically passing the buck, you're giving it to them and saying, listen, I didn't actually do, and so in this case, you can actually skip on error handling altogether, right? So you could say, you know what, I did my part, here's the promise to you, and you go ahead and attach any error handlers you want. I'm giving you, the caller, a chance to do that, but also giving you responsibility. Now, this actually often really does make sense. Now, the reason it makes sense is because often whoever is actually setting up the request or doing earlier processing may not really be equipped to handle the response. So for instance, let's imagine that we are writing code down, sort of well down our stack. I mean, still within the client side, but well down our stack, where we got the request for some data from the UI. Since we're separating concerns, we don't really know what that's for, right? We just know that the higher levels up want some data. So we go and we ask the server for that data. We get a promise. We do some transformations on that data. We do some transformation on that data, assuming that everything up to this point has been fine, and we return the result to the user, right? To the caller. Now let's imagine that at that point, the server failed or something else went wrong. Well, we don't really know what we're supposed to do because we don't know what this was for. Maybe this was the kind of request that whoever called it really doesn't care about it, and they can just try again in a few minutes. Maybe it's the user just is waiting for a response, and really they need to see a friendly error message. So it often actually makes sense to put that responsibility onto the caller. So basically, whoever is making a request in this setup is actually going to decide what happens when that request fails, right? And so it actually simplifies our architecture down the stream, so down in the stack quite a bit, because we now basically are going to pass. The only times that we actually do want to handle errors is when the errors are errors that we know about that the caller may not, right? Or may not understand. So oftentimes what might make sense for us is to actually catch errors do something with them, and then throw new higher level errors, where basically, for instance, we go ahead and we log at this level detailed information about what happened, but we then throw a very generic error saying request failed. And then what the caller, you'll say your controller, if you're in the Angular world, your controller will basically just get a rejection saying we've tried to make this request, it failed for unknown reasons, and your server will then be, so your controller will be able to communicate that information to the user. But again, in terms of does this information need to result in a pop-up, does it need to get logged, those are the kind of things that you often actually, your architecture becomes simpler if you can actually offload that responsibility onto the caller. Now let's talk briefly about testing promises. This is actually going to be very brief because testing promise code is actually remarkably easy. If you've done sort of testing of asynchronous code using Mocha or Jasmine using the done callback, it's a pain. And in contrast, this is how we write tests when we use promises. If we want to actually, so we have in this case a service. I'm kind of using Angular terminology. We're going to call get tasks, and we're going to attach a handler. And in this handler, we're going to make an assertion. And what's going to happen is if the assertion fails, the callback will throw an error, and the promise returned by .then will fail, will get rejected. And so all we then need to do is we just need to return from our test, we need to return a promise. So if you're using Mocha, Mocha is smart enough to know that if your test returns a promise, then it will wait for that promise to either resolve, in which case your test passes, or to time out, in which case your test fails, or to reject, in which case your test also fails. So this is really literally all you need to do. You just need to attach that return. That return becomes really important because in this case you are passing the buck, so to say, to Mocha. Mocha will score your tests based on rejection of your promises. That's really all you need to know about testing promise code. It's so much simpler. There's none of this ugly done callbacks that otherwise you would have with callbacks. Now let's talk briefly about making promises. And by making promises, I mean creating new promises. Now this, you need to do that a lot less often than you might think. And I think, and there's a really common, so this is how you would do it old style, using the deferred, in say Q or $Q, you would use the defer command. I'm not going to go through much of this, but let me just say that there is a sort of, lots of people call this the, not this specifically, but a lot of code that uses Q.defer falls under the umbrella what people call the defer anti-pattern. And the reason is that you very rarely need to do this. Now, this represents about the only valid case of using it when you've got a function that doesn't use promises, that uses callbacks, and you want to convert it into one that uses promises. So that's when you actually need to whip out something like that. Almost every other case, when what you want to do with defer can be done without it. Now, the other thing worth considering is that this is sort of old school. There's also the sort of ES6 style promises, which actually work a little differently. In this case, you basically got a promise constructor. In ES6, it will be a return new promise, capital P instead of $Q. But then the underlying implementation is the same. You basically, your promise constructor takes a function that takes resolve and reject callbacks. And inside of your function, you call one, inside of this function, you call one or the other. Now, this approach is preferred because it actually keeps you from the defer anti-pattern. But again, and it's still usually not necessary. So, and in fact, so this is about the only valid use case when you want to convert a promise, a function that takes callbacks into one that returns promises. Now, if that's the situation you commonly face, though, you should really consider actually writing a higher level function that does it for you. So here's an example. The Q library comes with a function called Denodeify. It takes a node style function and gives you a promise style function. And so then all you really do to convert it is just call Denodeify one function, you get the other function, and you use your new function. It's really that simple. Now you might think, well, what if I'm not using $Q? What if I'm using Angular? Well, this is what the implementation of Denodeify ends up looking like, roughly. And then after, I just did it last night, and then I figured I might as well actually go and put it on GitHub. So I'm going to, I created a repository, but I'll put this code there. And I was thinking of also maybe doing the jQueryify, which sort of do the same thing with jQuery style callbacks. But the idea is that this is a function that, given a node style function, will return a function that returns promises, and you could just put this in one place in your code, and then you could convert all of your functions that take node style callbacks to this format once and for all and never really have to. And then you really should almost never have to create new promises using either of the two approaches. Now, what does sometimes come in handy is creating new promises using really sort of this interface that gives you trivial promises. So $q.when returns a promise that resolves to x automatically, no unconditionally. $q.reject error returns a promise that rejects with the error e, right? Those two come in quite handy, and I'll talk in a second about when they come in handy, but those really are quite often useful, more so than the promise constructor. The promise constructor, every time you're trying to use the promise constructor or $q, you've got to ask yourself, do I have a good reason for this? Usually you don't. Now let's talk about some do's and don'ts of promises. So first of all, I mentioned earlier that promise chains are ugly. They are confusing, and really, there's no reason for them for you to do that. Now, breaking up them with variables is really far from ideal solution, the way I showed you, because that's actually, it ends up being in some ways more straightforward, but it ends up being way more code. What I recommend instead is breaking up your promise chains with meaningful functions. So in this case, we will have where your typical pattern would be that your typical function gets a promise, attaches one callback, maybe two callbacks, and returns the resulting promise. And now you can give them meaningful names, and you can actually be very clear about what each of those functions does. So in this case, get tasks gives us a promise for the actual list array of tasks, and get my tasks gives us a promise for the filtered array of tasks. And so we can then offer our caller an option of which one they want to call, and also it becomes a lot clearer to understand that how get my tasks different from get tasks is much, much easier to read than sort of long promise chains of promises. Number two, with promise interfaces, you gotta stay consistent. If your function returns a promise, sometimes it should return a promise always, because your caller should be able to call your function and immediately do .then. If they can't, you don't want them to have to check whether you actually return a promise or not. So you have to follow this approach that either you return a promise, either you never return a promise, or you always return a promise. Now, if you always return a promise, then sometimes there are edge cases. There are cases where you can't really return whatever it is that you're planning on doing, you don't have that promise. That's where $q.reject and $q.when come in really handy. So if you are trying to make sure that your function always returns a promise, what you should do is any exceptions, you should, instead of throwing, you should return a new rejected promise using q.reject. And if you want to return a plain value, because you've got a plain value on your hand, you should wrap it into a promise using q.when. And this way you can ensure the caller that your function will always return a promise, and they can safely start attaching callbacks to it. This is very important. Third is when in doubt, return a promise. I mean, if you're defining an interface and you're not sure whether your operation will eventually be synchronous or asynchronous, it's always better to go with asynchronous, because in this case, if you later have to change your mind, right, you can actually have that option, right? So if you're doing some file processing, you're using a library now that actually does it synchronously, but you know that maybe you later will switch to another library that will have to require an asynchronous interface. If you return a promise right now, your life in the future is going to become a lot easier. And then finally, I mentioned before, passing the buck is important, but passing the buck is different from just dropping it. So if you receive a promise, you normally would return a promise to the caller, right? And you would only be handling the errors that you actually are best equipped to handle. Your caller can figure out later what to do with the rejections that you gave them. However, if you don't return a promise, you gotta handle the errors, because you're not giving anyone else a chance or passing the responsibility for doing so. So really, either you handle all the errors or you return a promise. That sort of should be kind of the two options. And finally, it's really important to avoid optimistic code. Now, by optimistic code, I mean code which, when you are working in an asynchronous setup, you should not sort of write code that assumes that hopefully something have happened by then, where it's going to go and look in a variable and will just sort of expect that the value is there, right? Because that really ends up being really fragile. What you're better off is writing code that asks for a promise and returns a promise, right? And so in certain sense, promise-based architecture largely comes down to this idea, right? Is that you write your functions, and especially sort of further down as you comes from the server interaction, where every function basically receives a promise from someone else, does some manipulations in the callback, and returns it. So finally, if you really do want to write code that just goes ahead and reaches out and grabs a value and returns it regardless of whether it's available, you really got to at least name your functions accordingly so it's really clear to the user that those are dangerous functions that may backfire and that they really have to only know that they are allowed to use them in a context where they want to use them. So now let's talk briefly about some neat tricks that we could do with promises. And first, and this is kind of getting where the promises actually really start giving us leverage in sort of perhaps unexpected way. So one is that we can cache promises, right? So the same promise can be used multiple times, which means that what we could do is we could actually implement our get tasks in such a way that it won't actually make repeated requests to the server. What we will do instead is we'll have our promise saved in a task, in a variable. And the first time, and when the function gets called, we're going to actually set that if the task promise is not defined, we will actually get a new promise from the server. We will save it in this variable, and we'll return that variable. So what this means now, architecturally, is that your caller now is freed from the responsibility of wondering whether they're burdening you with too many requests, right? Your function can take care of caching now internally. Your caller always gets a promise. They can always ask for it. They always get it. They don't have to worry about whether you are whether they're bothering you too much, right? You just give them a promise. You can take care of at this point whether it's time to maybe make a new request and things like that, right? So this becomes really handy. A variation of that is prefetching. We could actually go ahead now and make a request to the server for the tasks, even before anyone asks for them, right? So as part of the loading of that module, we could go ahead and make a request to the server. When someone asks for tasks, we'll give them that promise. And the nice thing about it is that it doesn't matter. We don't need to worry here about when this request is, when we're going to get asked for tasks. Regardless of whether we get asked for them right away, when the result is not yet available, or if we get asked later when the result already is available. In either case, the caller will get back that variable, the promise, and they will then attach a callback. So the rest of the handling is completely the same, regardless of when the caller asks for tasks. So this gives us a good amount of flexibility. And finally, within this set is we can use promises to actually put requests on hold in a way that's transparent to the caller. So and this, I think, is actually really cool. So oftentimes, we could end up finding ourselves in a situation where our caller code wants to make a request, but they're not sure if it's yet the right time. So let's say that you're writing your controller, and your controller wants to go ahead and ask for data, but they only want to ask for the data if the user has already been authenticated, right? So you kind of now get tempted to say, well, the controller will check for authentication, and the controller will then, based on that, either wait longer or ask the underlying get function for data. This gets, of course, a little ugly because maybe your controller doesn't need to know whether the user has already been authenticated or not, right? Because that's really now mixing concerns. So what we can do instead is we could write our get function. We can implement a get function, which basically works like an HTTP get, but with one catch. That function will return a promise, and it will return a promise right away. But the promise that it will return will actually be waiting on two steps. It will first wait on the user actually becoming authenticated. And upon authentication, only upon authentication, it will actually make an HTTP request, ensuring that the HTTP request actually ends up being properly authenticated. And then it will return the result. Now, the cool thing about, so now in this case, we're assuming that there's already a service called user. The service user can give us a promise for the authentication event. And the cool thing about this is that we can now give our caller a simple function. We can say, here's your get function. If you want something, you want to make an authenticated request, just use this get function. And if the user is not yet authenticated, your request will simply get put on hold. So you don't need to wait to make that request. You can ask right away. And then once we figure out that the user is authenticated, then you're going to get your data. So you can start writing your code where it basically says, OK, well, we get here, and here is some content that appears when we've got the response back. And we're going to immediately ask for that content. Whenever it does come, we can actually insert it in that place. And in this case, if the user turns out takes extra 5 minutes to authenticate using some other widget, then the content will appear whenever they have authenticated. So this really simplifies our design. And finally, two more slides. Composing promises. So I'll talk about this very briefly, but the idea is that you can actually use promises in combination with functional programming. We have recently started adopting a library called Ramda, which is really awesome function for composition. And we have actually gone, because we love promises so much, and we've added an implementation, a function to Ramda called ppipe, which basically does promise-aware function composition. So the cool thing about this is that if you are into functional programming, if you're into composing functions, you could mix all of that with promises. So you basically now, if we're going to define our getExifDate function, which is a composition of 3 steps, and where the first step is actually asynchronous, and it doesn't matter. The first step is asynchronous. The second function and the third function are synchronous. And ppipe will actually take care of this for us. And we'll get back, at the end of the day, a promise. And we can proceed with the rest of our composition as if we were doing synchronous programming. And finally, the most awesome thing about promises is core-style generator magic. Now, this is unfortunately only available in ES6, but this is amazing. ES6 yield keyword allows you to write code that essentially unwraps promises in a way that's invisible, where getPromiseForData returns a promise, and on the other side of yield, data is going to be an actual value. And we can then continue with our code actually just using the values. Now, don't have time to get into this, but I encourage everyone to just sort of look up how core does it. And this is really, I think, where promises sort of come to their sort of full fruition. Thank you very much.